Hi, good afternoon. So in this video, I'm going to be explaining what is step-up converters. First of all, what are voltage regulators? That's what this hobby is basically about. So voltage regulators are basically that those kind of electronic devices. They maintain a fixed output voltage, irrespective of the changes to the input load or input voltage. So no matter what the input voltage is, voltage regulators they help to maintain a fixed output. So basically they manipulate the resistance in the circuit in order to regulate the output voltage. So that's the basic gist. Now there are multiple types of voltage regulators too. We have linear, we have switching. Linear, basically there's a lot of power loss of like operates at low efficiency. Switching, well, the basic difference between them both is switching regulators they operate at a very high frequency or at a high efficiency. Like high efficiency, it's more efficient than linear because there's less power dissipation. Basically, there's like most of its input power is transferred to the output with minimal power loss. So there's not a lot of power loss in switching regulators. Now the final topic, which is like final point, which is basically like the main difference. What is step-up converter now? So step-up regulators or step-up converters basically they convert a lower input voltage to a higher output voltage, as simple as that. So they act as they try to boost the amount of voltage. They boost the input voltage basically. So how they work, basically they store energy in inductor. As you can, like, this is the inductor, stands for L1. During like when the switch is on, like when the switch is on, when there's current in the circuit, step-up regulators they store energy in the inductor, and when the circuit is off, inductors release this energy to the output. So when this process is repeated again and again and again at a very high frequency, it results in a higher output voltage than how much it was actually like given in. So resulting in higher output voltage, though the input voltage is technically the same. So like there are many advantages of step-up converters. The first main advantage, as I already told, we can get a higher voltage from a lower voltage source itself. And yeah, that's it. So now we can start with this step-up converter. How do we, okay, I'm so sorry, 1 second. Yes. Okay, so now as you can see here, there's something special about this step-up converter. This step-up converter has an IC, as you can see in the between. This is called an MC34063. This is an IC, integrated circuit. It's a very popular IC and it's commonly used in step-up voltage regulators. So firstly we have yes, so as we have an IC here, we have different connections to the IC. So we have one pin to the input voltage source, that is the 12 volts. We have one pin from the IC to the ground. We have one pin to the positive of the inductor from the IC. We have one pin from, where is this going? We have one pin to the diode, the cathode of the diode, so the input voltage source. Okay, we have one pin connecting to the 100 microfarad capacitor between the pin 1 and 2. Pin 1 and 5, you can say. That 0 and 1. Then we have 330 microfarad capacitors between pin 6 and 5, pin 5 and 6. We have a 1.5 nanofarad capacitor, and we have a resistor from pin 3 to pin 4, and we have a resistor from, that's it, we have a resistor from pin 4 to pin 6, and finally we have one last resistor of 160 ohms. Then we have the voltage probe basically, and here we have the current A. So now once we assemble the circuit, we can wait, first actually, like about this IC in general. So like, why do we have this IC in the first place? Like, why do we have a M6 like MC, this particular type of IC? So basically, this basically, there are a lot of connections from this IC in this given circuit itself. So this IC regulates the output voltage by this IC, it regulates the output voltage by basically by it's a switching transistor nonetheless, that is connected to the inductor over here. So it regulates the voltage, the output voltage, by controlling the duty cycle. I'll explain that in a second. Now, first of all, when there's current in the circuit, for example, when the circuit is turned on, when there's voltage, when there's current in the circuit, the transistor is turned on. Okay, now what is the job of the inductor? Inductor is a device, it stores energy. So when the transistor is turned on, the inductor stores energy, and vice versa. Basically, and when the transistor is turned off, that is when there's no current in the circuit, the inductor is switched off. And that time, it releases all its stored energy, which is then rectified by this diode over here. And then it's finally delivered to the output. Now, the output voltage is regulated by basically manipulating the duty cycle of the switching transistor. So now, what is duty cycle? Duty cycle basically of a switching transistor, is switching power supply. In basic words, it's switching power supply and the amount of percentage that the transistor is on, or like in the state when it's actually like voltage is flowing through it, sorry, current is flowing through it. So the duty cycle is basically expressed in the form of a percentage, and it basically tells the amount of energy transferred from the input to the output in a circuit. That's basically it. So it's also it's controlled by the feedback basically. Now, what is feedback? Feedback, it's basically like feedback regulates and tells the desired, or like the amount of reference signal that you want. For example, feedback circuits, in the most basic words of it, it controls the output. That is the basic gist of it. Now, how does it do this? It's a closed loop. It's a closed loop in which some part of that output signal, it's fed back. As the word says, it's fed back. It's sent back to the input of the system to change the system's behavior like in its entirety. So the purpose of feedback circuit is, as I told, regulate, control, match, or for example, it's not just regulate output voltage. We want in some cases we want an input voltage to match some output voltage. So there we use feedback because we want to match those output. We want to increase output, decrease it, etc. So that is basically what feedback is. So now going back to it, we will. What else is there? Okay, now we can run this yet. Yes. Wait, how would I have failed to mention anything about resistors? Okay, resistors is there. Okay, then have I missed out anything? The output voltage is regulated. Everything is done. Now we can actually add a potentiometer also here between pin 6 and 7. I mean, if you want to like, it's optional though. Like we'll add the potential meter if you want to like control the output voltage also, but it's not needed. Then we have capacitors over here. Capacitors basically they filter out capacitors in this circuit. They basically provide a stable voltage regulation. That's it. And the resistors obviously they set the current limit and the feedback for the circuit and the voltage feedback for the circuit. Then okay, so the diode here, it has only like one job, that is it should make sure that the current only flows in one direction, and because if there is reverse current, that will damage the circuit, so it helps to prevent that. That's it. So basically this circuit provides an efficient and efficient way to set up a voltage step-up voltage regulator using this IC. Now going to split, we can see the graph. So we have the 5 milliseconds per division, we have voltage and we have current. The time is not given. Okay, basically 5 milliseconds. So that's there. So with this input and output voltage readings, we can just start the some common points from 12 to from input voltage 12 to till, well, the max output voltage we have taken right now in this graph, I think is there. I think we've taken up to 24. Okay, no worries. Okay, then 24. So that's it. That's all about step up voltage regulators. Thank you.